Hi, I'm Pete Shersby, and today on Make or Repair I'm going to look at this Enertec Schlumberger 4431 Programmable Function Generator. Now, to the best of my knowledge, I think it's in good working order, it's good condition, but I want to check it over before I put it up for sale. I got this in a job lot, I gave it a short test at the time, I noticed the keys are a bit sticky, but other than that, it's pretty well working, I think. So I'm going to pull it apart, fix the keys, look for any other obvious problems, sort out any capacitors, we'll go from there. Quick look, we've got sine wave, square wave, triangle waves and DC. In waveforms, of course, any amplitude or frequency within the limits. And in the mode we've got generated, synthesized, and we've got gated and triggered as well. Now the difference between generated and synthesized really relates to a trade-off between quality of the signal and accuracy of the signal. So synthesized is 50 parts per million, whereas generated is about 2% or thereabouts. I'll try and stick the things on the actual screen. But the total harmonic distortion on generated is going to be lower than synthesized. So you take your choice as to whether you want a clean signal or an accurate signal. You do at least have the choice. Per million. So gating obviously turns the signal on and off based on external signal, and trigger enables us to trigger the start, or we can use a manual trigger down here. It's up to us. We've got let's have a look. We've got symmetry, 80%, 50%, 20%. So for example, a square wave on 20% would give us a short pulse, and that's how it would look. We've got outputs, 50 ohm standard output here, that's great. We've got a TTL output here as well. Now it does have a note on here that to stop reflections you want a load of 50 ohms on that as well. We can choose megahertz, kilohertz, etc. I think we've got either 4.5 or 5 digits accuracy here on the display, and obviously a keypad here to enter data. Quick look on the back. Let's try and bring that into the middle of the screen so I can zoom in a little bit. There we go. So over here we have got our trigger input, and you can notice here that lots of things are actually in French as well as English, just to really help us out here. So we've got TTL, we can ground it, or we can go for ECL type inputs, which is quite unusual. And down here we've got GVC out, so voltage control out. So up here we've got time base, so we can put in an external time base if we want greater accuracy. And we've got an FM input as well, small fan, just some transistors, heat sinking. And over here we've got the remote control input, so GPIB style input over here. I'm not sure if that's serial or whether that is just a replica of the GPIB. We'll find out soon enough, I guess. This particular one is set for 0.8 amps, 240 volts, and has a slow blow fuse, and that's a lot really. Now before I move on, I am actually going to have a quick look inside, quick look at the capacitors in particular, and I also want to look to see whether it's got kind of like reverse suppression capacitors in here, because you know they would tend to be a bit dodgy if that is the case, and I know that this company has used them before, and it's also used some Schaefer input suppression, which hasn't been very reliable before on some other models. So don't know quite what this one's got in it at the moment, but I want to just take a look and make sure that everything looks good before I power it up for very long. Now I do have the service manual for this. So here is the service manual, and we can see there's some pretty good schematics and things like that. These are layouts, but they've actually done an X-ray view of this, so we can see both the top and the bottom traces with the component positions on them, which is pretty cool. Don't see that nowadays. So here's all our boards, here's our main trimmer components of our front and back panels, etc. And obviously loads and loads and loads of text. And this is indeed a service and technical manual, not just a user manual. So we begin to see all the theories of operations and the block diagrams and things like that now. And we do indeed, as we might hope, get down to circuit diagrams at the component level. Okay, we're in. So I'm shooting it sideways on my main camera instead of the top-down camera that I normally use, just because this has got a bit more resolution, in fact. I'm just taking a look at these caps over here. So this is the input stage, and I'm just going to actually on my service manual, and the reason is I can't actually see there's the cable coming in here, And I can see going to the board, and I can see the switch, and I can see some selection jumpers and things. I can see the fuse, and I can see the transformer, obviously. What I can't see is anything like any input X and Y caps or anything like that. This is of course a very old design. So here we go, here is our power supply circuit. So we can see that the mains just comes in, it goes through a fuse, a switch, and then through a voltage selection circuit into the primary side of the transformer, and then we've got loads of half wave rectifiers and full wave rectifiers coming out into the various voltages. So what we got there, plus 24, plus 15, minus 15, minus 24. Some non-regulated voltages that I can't quite see. 5 volts of course, 12 volts, minus 5 volts, and a fan connection. Now there's not a lot else going on there. I don't know the part numbers for those components, but so I don't need to worry at all really about the suppression. So thinking a bit more about these bigger caps just here. So I have no idea what make they are. I can't really see it. However, a very, very careful look around shows not the slightest sign of any corrosion or leakage or bulging or anything really. So I think I'm just going to leave those well alone. Yeah, I could replace them all, but you know, I don't see any need. Now I have noticed one little fault just down here, and that is this switch, and I can see that the PCB just here, which you can probably hear clicking, into which the back of that switch is soldered, is the back of the switch is pulled out of the sort of metal cradle. So it's probably functionally repairable in fact, and gives me a good opportunity to clean it, but I will need to take this PCB out, remove those switches, get it all cleaned and put it all back together again, which is a, you know, a bit of a pain in the bum, but you know, that's it really. 2, 3, 4. So it's got 4 BNCs actually soldered directly onto that board. It's going to make removing it a pain in the neck, and then of course they're fastened through onto this aluminium plate. So those are not going to be funny to remove. There's no serviceability there, that is for certain, because obviously the BNC goes through from that direction, and they are screwed. The bolts are between this PCB and the plate, so I can't get at those at all. So the only way I could take that off is to actually unsolder all of that. So it's easy enough to assemble, but to disassemble it I'd have to take out pretty much everything, and of course this board is connected to the bottom board, so yeah, really, that's not the best of designs. That's very awkward. Everything else looks physically okay. I'm not really seeing any issues at all. The usual dust, which I will blow out with a compressed air in a bit. A lot of relays on here. There's also a lot of adjustment points. We do have a useful point here for me to check all the voltages, so that's great. I will do that. All of these capacitors around here, on here, they look absolutely fine. That's truthfully, I think they may have been replaced at some point. Taking a closer look at this bottom corner one. Oh no, it's fine, it was just the way the light was on it. It looked like it might have had this particular capacitor right in this corner looked like it might have a little bit of a bulge, but in actual fact it hasn't. It was just the way the light was cutting across it, so that's absolutely fine. In terms of part numbers, almost all of this is 7/4 logic on this board. and all of the trimmers to adjust it are on here. I don't really want to try and trim anything up without checking it within its case, because obviously that will change the thermal performance quite a lot. In terms of getting the front panel on and off, it actually turns out to be surprisingly easy. Here's the front panel. Turn it all the way up. There you go. And here are its connections. So the front panel literally unclips using 2 clips, pulls out, and then you just pull these little cables out of these connectors. It doesn't come much easier than that. Now I think I might just take an opportunity to pop this off and have a little clean around behind the switches as well. Okay, let's just try that out. So just going to pop the bolts off this, and then hopefully I'll be able to pull this board out and get access to the switches. So I'm doing this now because even though I haven't tested it, I know I'm going to want to do those, and truthfully if I reassemble it and test it and it works, I won't want to take it apart again. Is this in the falling out stage yet, or has it still got another screw in? I think we've still got a pair of screws potentially. So you have to be cautious with these screws because sometimes there's something behind them in a bolt, and there we go, and we have it. Superb. So as you might expect, really just a load of 7/4 logic on here and a bunch of switches. Now these switches I know will actually pop apart, and they've got a little springy device in them to make them click, and a little contact disc. So I'll hopefully be able to show you that in a moment or two, and you just need a very small screwdriver to pop in and just unclip them. Conveniently, I do have some spares of these just in case I do ruin any, but should be able to clean them up. So in here we've simply got a very small spring in the centre with a little metal contact behind it. On the other side, inside the switch, we've literally got 2 little wires. So I do think I am going to need to, I mean, if they're all like that, then they're not really wonderful. A bit tightly packed though, getting them apart could be quite a challenge, because often I can get hold of this side of the clip, but yeah, the other side, yeah, not so much. Yeah, these are not the cleanest, are they? I mean, look at the state of that. Don't know if you can kind of see that on the camera very well, but yeah, it's not the cleanest of things. Alrighty. Okay, so I'll probably just stop filming there because I'm literally just going to take every top off across here. These will be a bit different, but yeah, because these are definitely pretty cruddy. Better now. So these are all nice and shiny now. Brush here, make sure we've got all the junk out of them. That's great. So those, I don't know if you can catch the light with those, but those are actually now shiny. Feels good, looks good. Quite a lot more to go. Okay, in terms of fitting these, slope is on the flap, is on the side, and this thing goes bump downwards and into a slot that runs the entire length, and there is a round section that's supposed to go through the middle, but only by like a fraction of a millimetre. Then the little disc goes on top. And finally, we put the spring onto it. Then, without disturbing it, we match the flats, put it on, and we're done. So that keypad is feeling great. Okay, so a few of these I'm just popping fresh springs in because the original spring was distorted and therefore it wouldn't click properly and release properly. So these switches, I believe, are actually available from Farnell's. Certainly, that's what I have written on my bag. Okay, every switch cleaned, inside and out. We'll give it a nice positive click. Superb. Let's get them connected up and see how it performs before I reassemble it all. Oh, well, there we go. Four, five, six. There you go. We hear a click and we're up and running. Superb. So now it is time to tackle this switch. So I suppose one question is, can I actually just push it in and it looks like it might be a yes actually. Just bending the rivets back round again so that we've got it sealed in. Yeah, they're supposed to join together. Oh, bugger me. Let's sort that very swiftly. Okay, I'm just going to take this and give it a good spray down with some compressed air before I reassemble it. So in terms of actually getting this back in its case, so, well, could be bad, could not be bad. This essentially slots in to take the board. All we've got to do is manage to slide this back in here in the right place. So, I'm going to be honest, it didn't come out very easily. But it went in just fine. Now, one of the reasons it didn't come out is because on the instruction book it told me how to disassemble it. First of all, it said take out the screw between the two BNC inputs, and it meant outputs, followed by take off the feet, which had no impact at all. There were 4 screws on the back that needed taking off instead, and it completely neglected to mention this locking screw just here. So yeah, overall, not the best of instructions on how to disassemble something. So just working through now, putting it all back together and cleaning as I go really. So clean, reassemble, and onwards we go. Alright, plug it in. So we're turned on, no nasty bangs, no nasty smells. And we're connected up to the oscilloscope, and I've just turned it on and it's coming at 1 kilohertz, and so we've got frequency selected just here. See the little LED. Let me just move this cable out of the way. That will stick out the way, stay out of the way will be helpful. So frequency 1.0000 valid kilohertz. Okay, and if we look up on the scope, that's probably not very easy to see. 1.00001 kilohertz is what that is metering at up at the top there, and that seems really, really good. Just a quick look at what voltage it's coming out at. So if I click peak amplitude, it's telling me that I've got V here now. It's 1.0 volts. And if I scale this up so we get a good scaling. Yeah, and this is telling me I've got a duty cycle of 50.0, 50.2, something like that. I've got a voltage peak to peak of 1.02. 1.0 here is what it says. But, you know, this is not a totally precise device. So yeah, really happy with that. That's really good. Sine wave, of course. Square wave, a little bit of overshoot as you'd expect. Triangle, that looks really good as well. And that's 1.00 volts. It's just a DC, which would give me offset, I think. Yeah. So this has switched automatically to offset because I picked DC. Yeah, cool. So back to here, back to frequency 1.00. So let's try 1 megahertz instead of 1 kilohertz. So there we go, megahertz here. Type in 1, and it's starting to go on there. Well, let's try 1.2345. Valid. And obviously just zoom in on this. 1.23451, maybe 2. But still looks pretty damn good. Duty cycle is 50 to 51. Yeah, very nice indeed. Let's try. So the maximum this can do is 19.99. $19.999. Lovely. So I'm going to try this now on a frequency meter. So I'm not sure that particularly shows up. Let's see if I can just sort of edge it out a little bit better and into better view. So we're supposed to have 19.99 and we've got 19.99991112, something like that. If I change this to a better measurement time, yeah, 19.9991. So that is pretty bloody good, I think, given its age, etc., etc., and the fact that we are not running it from an external standard. We've just got it on its normal standard. I'm going to put a spectrum analyzer on, I think, as well. Okay, so I've got the spectrum analyzer on. I've got this set to 1 megahertz. Spectrum analyzer is taking a look at that on minus 12 dB, and so I've got it set to 0.2 volts. Yeah, I think it sounds about right off the top of my head, but anyway. So that's absolutely fine. I think I'm happy with that. We've got a perfectly good 1 megahertz here. The second harmonic is very low, the third is a bit higher, as we might expect really. That's pretty good. And this, of course, this is on a generated sine wave, not a synthesized sine wave. If I go to synthesized, which you might expect the harmonics to change slightly. It's hard to tell. But they're pretty good, as we can see. Now, if I increase the voltage, they will go a bit higher, and that'll partly be because of the effect of the, it'll be beginning to, for auto low distortion, so that I don't get distortion added by the system itself. We can go for auto low noise instead, but you know, auto distortion is the right thing for this. Okay, because we don't want our system to add distortion to our measurement, because what I'm going to do now is I'm going to switch across measurement mode, and I'm going to go to harmonic distortion, and we'll have a look. Okay, so this is on synthesized. It's really zoomed in here. And yeah, here we go. Total harmonic distortion 0.6%, 0.7 nearly on that particular frequency and input level. If I change that synthesized, if I change to generated instead, yeah, you can see our primary signal versus our secondary is much better, 0.4, 0.39, 0.38. So this has got some averaging on at the moment so that we don't get carried away too much. But anyway, there we go, 0.3. We're about 0.35, 0.34%. We're about minus 50 dB in terms of THD. Alrighty. Now that's just a quick dirty measurement, but it gives you a good feel. Yeah, pretty nice, pretty slick, like it. Anyway, hope you enjoyed that. So quick look at that. So this had some sticky buttons to begin with, that's all I knew about it. It seemed to sort of work. I stripped all of those buttons off, cleaned them out, rebuilt them, and they're all clicking nicely now and responsive, and there's no problem typing in values, etc, etc. Cleaned all the outputs as usual. When it was apart, I took a good look at the capacitors. They all look great. Also took a look to see if there was any input filtering that needed to be sorted out. The dreaded reefer caps, there is not. This is a very simple power supply. And I did notice that there was a switch that had sort of delaminated, if you like, in the back, which I've sorted out and cleaned as well. So that's all working nicely now. And what else was there to do on this? Not a lot else, in truth. Just blew out the dust and reassembled it and tested it. Bit of a wipe down to clean all the front panel up, etc, etc. And I'm pretty happy with this. It's a bit of a shame I'm not going to be keeping it, but there's a limit as to how much I can have in my lab. So I think someone's going to get a fairly nice piece of test equipment, certainly for the price. And there's certain things that are really good about it. So for example, if you got a cheap arbitrary generator, for example, then it might be able to go to 20 or 40 megahertz, let's say. That's great. It will do that probably for a sine wave and a square wave, but it's not going to do it for a triangle. I think I'm going to call that a day. Hope you enjoyed it. No real repair, just a bit of refurbishment, but still, you know, taking those switches apart is perhaps quite interesting to some people. Hope you enjoyed it. If you did, please don't forget to like and subscribe, and I'll see you next time. Take care. Bye for now.